Good evening. Tonight, as we drift off to sleep, we will travel back to a world that was confined to this planet. For as long as humans have existed, we have looked upward. Before cities filled the night with artificial light, before telescopes revealed distant planets and galaxies, before rockets carried machines and people beyond the atmosphere, there was only the simple wonder of the sky above. A blanket of darkness scattered with countless points of light. A place that seemed impossibly far away, yet somehow deeply connected to us. Ancient civilizations watched the movement of the stars and used them to measure time, navigate across oceans, and tell stories about the mysteries above. Farmers looked to the heavens to understand the changing seasons. Travelers followed familiar constellations across unknown landscapes. Philosophers wondered what existed beyond the blue horizon of the daytime sky. For thousands of years, space was a place of dreams and imagination. The moon was a distant companion that followed humanity through the night. The stars were tiny fires burning across an endless universe. They inspired stories, myths, and questions that had no answers. But in the middle of the 20th century, something changed. The dream of reaching the heavens began to transform into reality. The same rockets that once carried weapons across battlefields would eventually carry instruments of discovery. The same mathematics used to calculate the movement of machines would allow humans to break free from Earth's gravity. And the same curiosity that had drawn people to look upward for generations would push them farther than anyone had ever imagined. The journey into space would not begin with peace alone. It would begin during one of the most tense periods in modern history. After the Second World War ended in 1945, the world entered a new era of uncertainty. Two powerful nations emerged as rivals, the United States and the Soviet Union. Their competition would shape global politics for decades, creating what became known as the Cold War. It was a conflict unlike any that had come before. There were no traditional battlefields where armies fought directly against one another. Instead, the struggle took place through technology, science, military strength, and influence around the world. And soon, the newest frontier became the most important symbol of all: space. Above the atmosphere, beyond the reach of ordinary life, existed a place where neither nation had ever traveled. Reaching space meant more than scientific achievement. It represented power, intelligence, and the ability to accomplish what had once seemed impossible. The first country to place an object into orbit would not simply launch a satellite. It would announce to the world that it possessed the knowledge and technology to reach beyond Earth. The race had begun. In the quiet corners of laboratories and research facilities, scientists worked late into the night. Engineers studied complicated equations beneath the glow of desk lamps. Metal workers shaped enormous machines that would one day rise into the sky. Astronauts and cosmonauts trained their bodies and minds for journeys into an environment humans had never experienced. The work was difficult, dangerous, and often uncertain. Every launch carried the possibility of failure. Every mission required solving problems that had never been solved before. Scientists were not simply building rockets, they were creating an entirely new chapter of human history. The space race was filled with moments of triumph and moments of tragedy. It brought humanity closer to the stars, but it also revealed the risks involved in leaving our home planet. It showed what people could accomplish when thousands of minds worked toward a common goal, while also reminding us of the enormous challenges that came with exploring the unknown. It was a story of astronauts floating silently above the Earth, watching continents drift beneath them. It was a story of massive rockets standing motionless on launch pads in the darkness before sunrise. It was a story of radio signals traveling across the planet, carrying messages from machines and people far beyond the clouds. It was a story of a small blue world becoming visible from the emptiness of space. And, perhaps most importantly, it was a story about humanity's relationship with the universe. The space race was not only about reaching the moon. It was about changing the way people saw themselves. For centuries, Earth had been the entire known world. But when humans finally escaped its surface and looked back, they discovered something profound. Our planet was smaller than we imagined, a fragile sphere surrounded by endless darkness, a place without visible borders, where all of human history had unfolded on a tiny patch of land floating through space. The astronauts who travel beyond Earth often described a feeling of connection and wonder when they saw the planet from above. From hundreds of miles away, political conflicts disappeared. National boundaries vanished. What remained was a beautiful and delicate home. The journey to space began as a competition between nations, but it became something larger. It became a reminder that curiosity is one of humanity's greatest forces. Tonight, as we begin our journey through the history of the space race, we will travel back to a time when the future seemed uncertain and the stars seemed just slightly within reach. We will visit the early dreamers who imagined leaving Earth. We will follow the scientists who built the first rockets. We will listen for the faint signals of the first satellites crossing the night sky. We will meet the astronauts who risked everything to travel into the unknown. And we will eventually arrive at the moment when human footsteps touched another world. So settle in, let the room grow quiet, and imagine the night skies of the past. Imagine looking upward in the years before anyone had ever left Earth. Imagine wondering what waited beyond the clouds. Because this is the story of the space race. A story of ambition and discovery. A story of rivalry and cooperation. A story of courage, curiosity, and the endless human desire to explore. A story that began beneath the same stars we still look up at today. Long before rockets stood on launch pads and long before humans floated silently above the Earth, there was a much simpler beginning to the story of space exploration. There was only a question: what exists beyond the sky? For thousands of years, humanity looked upward and wondered about the vast world above. To early observers, the sky was not empty. It was alive with mystery. The moon changed shape throughout the month, growing from a thin crescent into a bright circle before slowly fading away again. The planets moved differently from the stars, wandering across the night sky in patterns that fascinated early astronomers. The sun brought warmth and life, yet its true nature remained unknown. The heavens were a place of beauty, but they were also a place of unanswered questions. For much of human history, space remained beyond reach. The distance between Earth and the stars seemed impossible to overcome. The first major step came from learning to understand the universe itself. Ancient astronomers carefully recorded the movements of celestial objects. They created calendars based on the stars and developed mathematical systems to describe the patterns they observed. Without modern instruments, they studied the heavens using only their eyes, patience, and imagination. They did not know it at the time, but these early observers were laying the foundation for a future where humans would one day travel beyond the atmosphere. The idea of leaving Earth first appeared not in laboratories, but in stories. For centuries, writers imagined journeys to the moon and distant worlds. These tales allowed people to explore possibilities that science had not yet achieved. The idea of traveling through space existed in human imagination long before technology could make it real. The moon became a symbol of possibility. It was close enough to see clearly, yet far enough away to remain mysterious. People wondered what its surface was like, whether other worlds might contain life, and whether humans could ever leave the ground beneath their feet. Then came a period of scientific change that would transform these dreams into something more practical. During the 17th century, improvements in astronomy changed humanity's understanding of the universe. The invention of the telescope allowed people to see farther than ever before. Suddenly, the moon was no longer just a glowing circle in the sky. Its surface appeared to have mountains, valleys, and landscapes. The universe became larger. And with each discovery, the possibility of exploration seemed a little less impossible. Scientists began to understand the laws that govern motion and gravity. These discoveries would eventually become essential for space travel. If an object could be launched with enough speed and controlled accurately enough, perhaps it could escape Earth's pull. The idea was simple. The challenge was enormous. For a long time, rockets were mostly objects of entertainment and experimentation. Early rockets had existed for centuries, used in celebrations and warfare, but they lacked the power and control needed for exploration. A journey into space required something completely different. It required precision. It required powerful engines. It required an understanding of physics that was still developing. At the beginning of the 20th century, a small group of visionaries began seriously considering the possibility of spaceflight. One of these dreamers was a Russian schoolteacher and scientist named Konstantin Tsiolkovsky. Living far from the major scientific centers of Europe, he spent years thinking about the possibility of humans traveling beyond Earth. Tsiolkovsky imagined enormous spacecraft, space stations, and journeys to other planets. He understood that rockets powered by chemical fuels could theoretically provide the speed needed to leave Earth. His ideas were far ahead of his time. To many people, traveling into space seemed like fantasy. But Tsiolkovsky treated it as a scientific problem waiting to be solved. Across the world, other pioneers shared the same curiosity. In the United States, Robert Goddard became fascinated with the possibility of rockets reaching beyond Earth. While many people dismissed his ideas, he continued experimenting. In 1926, he successfully launched the world's first liquid-fueled rocket. The small machine only flew briefly, rising into the cold air of Massachusetts before returning to the ground. To observers, it may not have seemed like a historic moment, but it was. That quiet launch represented the beginning of a new era. For the first time, a rocket powered by liquid fuel had demonstrated that controlled flight using this technology was possible. The dream of reaching space had taken its first small step toward reality. Meanwhile, in Europe, scientists and enthusiasts gathered to discuss the future of rocketry. Groups of engineers began studying how rockets might one day carry instruments, and perhaps even people, beyond Earth. They met in small clubs and private gatherings, sharing ideas that seemed almost impossible. But throughout history, many great achievements begin with ideas that initially sound unrealistic. The first airplanes seemed impossible. The first submarines seemed impossible. The first journey to the moon seemed impossible. Every great exploration begins as a thought in someone's mind. By the 1930s, rocket science was slowly moving from imagination into experimentation. Engineers were building larger rockets and learning more about propulsion, guidance, and materials. But the world around them was changing. Political tensions were rising. Nations were preparing for conflict. And the same rocket technology that could one day open the door to peaceful exploration would soon become connected to warfare. The road to space would not be a simple journey of discovery. It would pass through one of the darkest chapters of human history. The rockets that carried humanity toward the stars would first be developed for a very different purpose. Yet, even during these difficult years, the dream remained. The dream that one day, humans would leave the surface of Earth. The dream that the moon was not just something to observe, but somewhere to visit. The dream that the stars were not distant decorations in the night sky, but destinations waiting for future generations. And as the 20th century continued, those dreams would begin moving faster than anyone imagined. The age of rockets was coming, and with it, the beginning of humanity's journey beyond Earth. The dream of reaching space had existed for generations, quietly growing in the minds of scientists, writers, and inventors. But dreams alone could not overcome the immense challenges of leaving Earth. A rocket powerful enough to escape gravity required advanced engineering, precise calculations, and materials capable of surviving tremendous forces. By the early 20th century, scientists were beginning to understand how such a machine might be built. But before rockets would become vehicles of exploration, they would first become instruments of war. The path toward space would take an unexpected turn during one of the most devastating conflicts in human history. The Second World War transformed nearly every area of science and technology. Nations around the world invested enormous resources into developing new machines of war, from aircraft and radar systems to advanced weapons that had never existed before. Among these developments was a new generation of rockets. In Germany, a group of engineers began working on a project that would change the future of rocketry forever. Their goal was not to reach the stars. Their goal was to create a weapon capable of traveling farther and faster than traditional artillery. At the center of this effort was a young engineer named Wernher von Braun. From an early age, von Braun had been fascinated by space travel. Like many rocket enthusiasts of his generation, He dreamed of humans traveling beyond Earth. He imagined spacecraft, lunar journeys, and exploration of other worlds. But the realities of the 1930s and 1940s placed rocket research under the control of military programs. The same technology that might someday carry explorers into space could also carry explosives across great distances. In a secret research facility at Piemont, located along Germany's Baltic coast, engineers began developing a powerful new rocket called the V-2. The facility was isolated and heavily guarded. Scientists and technicians worked long hours designing, testing, and improving the complicated machine. The V-2 was unlike anything that had come before it. It was the world's first long-range guided ballistic missile. Standing nearly 46 feet tall, the rocket was an impressive engineering achievement. It used liquid fuel, sophisticated guidance systems, and powerful engines to travel beyond the range of conventional weapons. From a technological standpoint, it was revolutionary. From a human standpoint, it was tragic. Beginning in 1944, V-2 rockets were launched against targets in Europe, including cities such as London and Antwerp. Thousands of people were killed or injured by these attacks. The rocket represented a troubling contradiction. It was a remarkable scientific achievement created during a terrible period of destruction. The engineers who built it were advancing the possibilities of flight, but they were doing so within the machinery of war. As the war moved toward its conclusion, both the United States and the Soviet Union understood the importance of capturing Germany's rocket technology. The future would belong to whoever possessed the knowledge needed to build the next generation of rockets. In the final months of the war, Allied forces raced to collect German scientific research, equipment, and personnel. The United States launched a program known as Operation Paperclip, which brought many German scientists and engineers to America to continue their work. Among them was Wernher von Braun. The Soviet Union also captured rocket technology and recruited German engineers of its own. Both nations recognized that rockets would play an important role in the future. At first, these rockets were viewed primarily through a military lens. They could deliver weapons across continents. They could strengthen national defenses. They could change the balance of power between rival nations. But hidden within these machines was another possibility: the possibility of exploration. The same rocket that could travel hundreds of miles through the atmosphere might one day travel thousands of miles into space. The same engine designed for warfare might someday carry humans toward the moon. After World War II ended in 1945, the world entered a new period of uncertainty. The United States and Soviet Union emerged as the two dominant global powers, each representing different political systems and competing visions for the future. The Cold War had begun. And while the two nations avoided direct military conflict with one another, they competed in nearly every other area. Science became a battlefield. Technology became a demonstration of national strength. And rockets became symbols of progress. The race to develop better missiles naturally led toward the possibility of reaching space. If a rocket could travel high enough and fast enough, perhaps it could place an object into orbit around Earth. This idea had fascinated scientists for decades. Now, for the first time, it seemed possible. Throughout the late 1940s and early 1950s, rocket research continued on both sides of the Iron Curtain. Engineers tested new designs, improved engines, and learned from every launch. Many of these early experiments ended in failure. Rockets exploded on launch pads. Engines malfunctioned. Guidance systems failed. But each failure provided new information. Each mistake brought scientists one step closer. The process was slow and often frustrating. Behind every successful launch were thousands of calculations, countless hours of testing, and the patient work of people whose names would never appear in history books. Engineers checked measurements again and again. Technicians assembled delicate components by hand. Scientists studied data from brief flights lasting only minutes. The future of space exploration was being built quietly, piece by piece. By the middle of the 20th century, humanity stood at the edge of a new frontier. The rockets were ready. The knowledge was growing. The dream that once belonged only to storytellers and visionaries was becoming an achievable goal. Soon, A machine would leave Earth and enter the darkness beyond the atmosphere. Soon, humanity would hear a signal from above the clouds. And when that moment arrived, the world would never look at the night sky the same way again. In the years following the Second World War, the world was left with the difficult task of rebuilding. Cities that had once been filled with life were damaged and silent. Millions of people were beginning the long process of returning to ordinary routines after years of uncertainty and sacrifice. But beneath the surface, a new tension was forming. The alliance that had defeated Nazi Germany was beginning to disappear. The United States and the Soviet Union, once partners in the fight against a common enemy, were now becoming rivals with very different ideas about the future of the world. This rivalry would shape the second half of the 20th century. It would influence politics, science, culture, and technology. And eventually, it would carry humanity beyond the boundaries of Earth. The period became known as the Cold War. Unlike previous conflicts, the Cold War was not defined by a direct war between the two major powers. Instead, it was a long struggle for influence and superiority. Both nations built enormous military capabilities, developed new technologies, and competed to prove that their system was stronger. The United States represented a capitalist democracy, while the Soviet Union promoted a communist system led by a centralized government. Around the world, countries watched as these two superpowers expanded their influence. The competition reached into nearly every area of life. Athletes competed for national pride. Scientists competed for discoveries. Artists and musicians reflected the cultural differences between the two societies. And engineers looked toward the sky. Space became the newest and perhaps most dramatic stage for this rivalry. At first, the idea of exploring space was not the primary goal of either nation. The rockets developed after World War II were mainly viewed as military tools. They represented the ability to deliver weapons across great distances, and they offered a strategic advantage during a time when both countries feared the possibility of another major conflict. But rockets represented something else too. They represented possibility. A missile that could travel thousands of miles could also potentially carry a satellite into orbit. A powerful engine designed for military purposes could eventually carry instruments, animals, and even people into space. The question was no longer simply whether humans could imagine traveling beyond Earth. The question was whether they could build the machines to do it. In the late 1940s and early 1950s, both nations began expanding their rocket programs. In the United States, researchers continued developing rocket technology with the help of German engineers brought over after the war. At places such as the Army's rocket development facilities, scientists studied how to create larger and more powerful launch vehicles. Wernher von Braun and his team continued their work, now focused on advancing American rocket capabilities. The Soviet Union followed a similar path. Under the leadership of Soviet engineers, including Sergei Korolev, the country developed its own rocket program. Korolev, whose name remained secret for many years, became one of the most important figures in the Soviet space effort. He shared the same dream that inspired many early rocket pioneers. He believed rockets could be more than weapons. They could become vehicles of exploration. But the political environment surrounding him was complicated. Soviet scientists worked under intense pressure, knowing that success could bring recognition and failure could have serious consequences. Behind closed doors, teams of engineers in both countries worked towards similar goals. They studied propulsion systems. They tested new designs. They built enormous rockets that seemed almost impossible compared to the machines of previous generations. The atmosphere of the time was filled with both excitement and anxiety. The world had entered the atomic age only a few years earlier. The development of nuclear weapons had shown humanity the incredible power of modern science, but it had also revealed the dangers that came with that power. Now, the same scientific knowledge that could create weapons capable of destruction might also open the door to exploration. Space represented a strange contradiction. It was born from competition, but it promised cooperation. It was connected to military power, but it inspired dreams of discovery. It was a symbol of rivalry between nations, yet it belonged to all of humanity. The first major step toward space would come through a surprisingly peaceful goal. a scientific project designed to study Earth from above. During the 1950s, scientists around the world began planning an ambitious effort called the International Geophysical Year. This global scientific collaboration aimed to study Earth's atmosphere, oceans, weather, and natural systems. One of the most exciting possibilities was launching an artificial satellite into orbit. For decades, scientists had imagined placing a small object around Earth. Now, advances in rocket technology made that dream achievable. Both the United States and Soviet Union announced plans to launch satellites as part of the project. Publicly, it was presented as a scientific achievement. Privately, both nations understood the deeper meaning. The first country to place a satellite into orbit would demonstrate that it possessed the rocket technology needed to reach space. And, perhaps even more importantly, it would prove that it could potentially deliver objects across the globe. The race had quietly begun. Scientists and engineers worked late into the night, often with little public attention. Their work was detailed and demanding. A satellite required not only a powerful rocket but also reliable electronics, communication systems, and instruments capable of surviving the harsh environment beyond Earth. Every component mattered. A single failure could end the mission. A single success could change history. As the decade moved forward, the tension between the United States and Soviet Union continued to grow. The world waited. The rockets stood ready. The scientists prepared their final calculations. And high above the planet, beyond the reach of ordinary human experience, a new frontier was waiting. Soon, for the first time, a human-made object would break free from Earth and enter orbit. Soon, people around the world would look upward and realize that the age of space had truly arrived. The sky was no longer only a place to dream about. It had become a place humans could reach. In the quiet months of 1957, something extraordinary was about to happen. For thousands of years, humans had looked into the night sky and wondered about the possibility of reaching beyond Earth. Generations of astronomers had studied the stars, writers had imagined journeys to distant worlds, and scientists had spent decades trying to turn those dreams into reality. Now, for the first time, a human-made object was preparing to leave the planet and enter the vast darkness above. It was not a spacecraft carrying astronauts. It was not a large machine filled with advanced instruments. It was a small metal sphere, no larger than a beach ball. But its importance would be enormous. Its name was Sputnik. The story of Sputnik began with the Soviet Union's determination to demonstrate its growing technological abilities. While the United States and Soviet Union were competing in many areas during the Cold War, the race to space offered something different from traditional military competition. It was a chance to show the world what science and engineering could accomplish. The Soviet rocket program had been developing rapidly under the guidance of brilliant engineers, including Sergei Korolev, the mysterious figure who would later become known as the chief architect of the Soviet space program. Korolev understood that reaching orbit would require a powerful rocket capable of escaping the pull of Earth's gravity. The task was incredibly difficult. A satellite had to travel at exactly the right speed and altitude. Too slow, and it would fall back to Earth. Too fast, and it could escape into space. The balance between gravity and motion had to be perfect. The engineers were not simply launching an object upward. They were placing something into a carefully controlled dance around the planet. The rocket chosen for the mission was based on Soviet missile technology. It was enormous compared to previous rockets, standing tall against the landscape of the launch site in Kazakhstan. On the evening of October 4th, 1957, the countdown began. The launch took place from the Baikonur Cosmodrome, a remote facility surrounded by wide-open landscapes. Engineers, technicians, and officials watched as the rocket prepared to leave the ground. There was uncertainty. There was tension. There was the possibility that years of work could disappear in a matter of seconds. Then the engines ignited. The rocket rose slowly at first, pushing against the heavy force of Earth's gravity. Flames illuminated the darkness beneath it as the machine climbed higher and higher into the sky. For the scientists watching below, the moment represented the result of years of calculations, experiments, and persistence. The rocket disappeared into the night. And then came the signal. A simple sound, a repeating series of radio pulses traveling from above Earth.
Beep, beep, beep.
Sputnik had reached orbit. Humanity had created its first artificial satellite. The little metal sphere was now circling the planet, traveling through space at thousands of miles per hour. It was a moment unlike any other in history. For the first time, something created by humans was no longer bound to the surface of Earth. A machine was now moving through the heavens. Around the world, people listened carefully as Sputnik's signal passed overhead. Radio operators tracked its movement. Scientists studied its orbit. Ordinary families looked up at the night sky, knowing that a small piece of human technology was moving silently above them. The satellite itself was simple. It carried no cameras. It performed no complicated experiments. Its main purpose was to transmit a radio signal and prove that reaching orbit was possible. But that simple signal carried a powerful message. The Soviet Union had reached space first. In the United States, the news created shock and concern. Many Americans had believed that their country held the advantage in science and technology. The launch of Sputnik challenged that belief. If the Soviet Union could place a satellite into orbit, many wondered what else it might accomplish. Could the same technology launch military weapons? Could it send objects across continents? Could it eventually place humans into space? The peaceful little satellite became a symbol of both wonder and anxiety. It represented a remarkable scientific achievement, but it also intensified the fears of the Cold War. The United States responded quickly. Government leaders recognized that space exploration was no longer simply a scientific curiosity. It had become a matter of national importance. The launch of Sputnik encouraged greater investment in science education, engineering programs, and rocket development. It helped inspire the creation of new organizations dedicated to space exploration. The race had officially begun. But beyond the politics and competition, Sputnik represented something much larger. It was the first moment when humanity truly entered the space age. The boundary between Earth and the universe had become thinner. The sky, once thought of as unreachable, had become a place where human creations could travel. Imagine standing outside on a clear autumn night in 1957. The air is cool. The streets are quiet. Above you, the familiar stars shine as they always have. But somewhere among those distant points of light, something new is moving. A small metal sphere is passing overhead. It carries no human passenger. It makes no sound that your ears can hear. But it is proof that the world has changed. For the first time in history, Earth is no longer the only place where human-made objects exist. The planet itself has become part of a larger environment. The age of space has arrived. In the months and years that followed, Sputnik would inspire new missions, new discoveries, and a dramatic competition between two nations determined to reach farther than the other. The first satellite was only the beginning.
Soon, humans would follow.
Soon, the quiet beeps from a distant machine would be replaced by human voices traveling through the darkness. And the dream that had existed for centuries would finally become reality. The sound was simple, a small, repeating signal traveling through the darkness above Earth.
Beep, beep, beep.
For people around the world, the signal from Sputnik represented a remarkable scientific achievement. It was proof that humans had finally reached beyond the atmosphere and placed a machine into orbit. But for many Americans, the moment carried another meaning. It was a wake-up call. The United States had entered the space age, but it had not entered first. The launch of Sputnik in October 1957 created a sense of urgency throughout the country. The Soviet Union had demonstrated that it possessed advanced rocket technology, and many Americans wondered what this meant for the future. The competition that had already existed on Earth had now expanded into the heavens. Space had become the next frontier of the Cold War. In the months following Sputnik, newspapers, politicians, scientists, and ordinary citizens all began asking the same question. How had the Soviet Union achieved this before the United States? The answer was complicated. The United States had many talented scientists and engineers working on rocket technology, but its early efforts were divided among different branches of government and military programs. The Soviet Union had focused its resources on developing powerful rockets, partly because of its need to match America's nuclear capabilities. Those same rockets could later be adapted for space exploration. The United States had been working toward launching its own satellite through a program called Vanguard, led by the United States Naval Research Laboratory. The goal was ambitious. This small satellite would be placed into orbit as part of the International Geophysical Year, a worldwide scientific effort to study Earth. But progress was slower than expected. When Sputnik succeeded, the pressure increased dramatically. The first American attempt to respond came quickly. On December 6, 1957, the Vanguard rocket prepared to launch from Cape Canaveral, Florida. Thousands of people watched as cameras captured the moment. The mission represented America's chance to demonstrate that it could also reach space. But within seconds, the rocket failed. The engines ignited. The vehicle lifted briefly from the launch pad. Then, just a few feet above the ground, the rocket lost power and collapsed back down. The explosion was broadcast to the world. For Americans watching at home, it was a painful moment. The failure became a symbol of the challenge ahead. Space exploration was not simply a matter of ambition. It required solving some of the most difficult engineering problems humans had ever faced. A rocket was a delicate balance of power and precision. Every engine had to work perfectly. Every calculation had to be accurate. Every component had to survive tremendous forces. There was no room for mistakes. But despite this setback, American scientists continued working. Another team was preparing a different approach. The Army Ballistic Missile Agency, led by engineers including Wernher von Braun, had been developing its own rocket system. Their vehicle, called Jupiter-C, had already completed successful tests and showed promise as a launch platform. The United States decided to move forward with this program. On January 31, 1958, the rocket launched successfully from Cape Canaveral. At the top of the rocket was a small satellite called Explorer-1. It was America's first artificial satellite. The mission marked an important moment in the space race. Explorer-1 was different from Sputnik because it carried scientific instruments designed to study the environment around Earth. Among its discoveries was evidence of radiation belts surrounding the planet, later known as the Van Allen radiation belts. The United States had reached space. But the competition was only beginning. The events of 1957 and 1958 changed America's approach to science and technology. Leaders recognized that space exploration required coordination on a national level. A new organization was needed, one that could bring together scientists, engineers, and resources from across the country. On October 1, 1958, the National Aeronautics and Space Administration, known as NASA, officially began operations. NASA was created with a peaceful purpose, exploring space and advancing knowledge about the universe. Its mission was enormous. The agency would study Earth from above, develop new spacecraft, train astronauts, develop rockets powerful enough to travel beyond orbit, and eventually attempt something that still seemed almost impossible: landing humans on the moon. The creation of NASA represented a new chapter. Space exploration would no longer be scattered among separate programs. Instead, the United States would have a dedicated organization focused on reaching beyond Earth. Thousands of people would soon become part of this effort. Scientists would calculate complex flight paths. Engineers would design spacecraft. Technicians would build machines capable of surviving extreme environments. Doctors would study how the human body responded to spaceflight. And astronauts would prepare themselves for journeys into the unknown. Behind every mission would be countless people whose names would never become famous. The space race was not only about astronauts. It was about the thousands of individuals working quietly behind the scenes. A person checking a measurement on a blueprint. A technician testing a small electronic component. An engineer reviewing data late at night. A scientist solving a problem that had never been encountered before. The dream of space was becoming a reality through ordinary people doing extraordinary work. As NASA began its first projects, the United States looked toward the next challenge:
sending humans into space.
The idea carried enormous risks. No one knew exactly how the human body would react beyond Earth's atmosphere. No one knew how astronauts would survive launch, weightlessness, or re-entry. But the questions had to be answered. The Soviet Union had already proven that reaching orbit was possible. Now the next milestone awaited. A human being would soon leave Earth. The world would hear a voice from above the clouds. And the space race would enter a new and unforgettable chapter. The machines had gone first. Now humanity was preparing to follow. Before humans could journey into space, scientists had to answer a question that had never been tested before. Could life survive beyond Earth? For centuries, people had imagined traveling to the moon and exploring distant worlds. Writers had described adventures among the stars, and scientists had calculated the possibilities of spaceflight. But imagination could only take humanity so far. The reality of space was completely unknown. Above Earth's atmosphere was an environment unlike anything humans had ever experienced. There was no breathable air, no familiar gravity, and no protection from the harsh conditions beyond the planet's surface. Scientists did not know how the human body would react. Would people be able to survive the force of launch? Would they be able to function without normal gravity? Would returning to Earth be possible? Before placing astronauts inside spacecraft, researchers needed answers. And so, the first pioneers of the space age were not humans. They were animals. The earliest travelers into space were small creatures chosen because they could help scientists understand how living bodies responded to extreme conditions. These missions were not only technical experiments. They represented the first steps towards sending people beyond Earth. In the years after World War II, both the United States and the Soviet Union began conducting high-altitude rocket experiments. Scientists launched animals aboard rockets to study the effects of acceleration, vibration, and weightlessness. The flights were often brief. A rocket would rise above the atmosphere, carry its passenger into an unfamiliar environment, and then return to Earth. Each mission provided valuable information. Scientists measured heart rates. They studied breathing patterns. They observed behavior during flight. Every piece of data brought humans one step closer to space. In the United States, researchers experimented with animals including mice and monkeys. One of the earliest American space travelers was a small rhesus monkey named Albert II. In 1949, Albert II became the first monkey to reach space when he was launched aboard a V-2 rocket. The flight demonstrated that living creatures could survive the journey beyond Earth's atmosphere, although the mission ended tragically during re-entry. These early experiments were filled with uncertainty. Scientists were entering a completely new field, learning through trial and error. The technology was still developing, and every launch carried risks. The Soviet Union was also conducting animal experiments, and eventually one small dog would become one of the most famous figures in early space history. Her name was Laika. Laika was a stray dog found on the streets of Moscow. Soviet scientists selected her because they believed stray dogs had adapted to harsh conditions and would be capable of handling the demands of spaceflight. In 1957, shortly after the success of Sputnik 1, the Soviet Union prepared a new mission. This time, the goal was not just to send a satellite into orbit. The goal was to send a living creature around Earth. The spacecraft was called Sputnik 2. Inside was Laika. On November 3, 1957, Sputnik 2 launched into space. The small dog became the first living being to orbit Earth. For people around the world, Laika's journey captured the imagination. Newspapers shared her story, and she became a symbol of exploration and scientific progress. But the reality of the mission was more complicated. At the time, the spacecraft was not designed to return safely to Earth. Laika's mission was intended to gather information about surviving in orbit, but she was not expected to come home. The details of her flight were kept secret for many years. Later information revealed that Laika survived only a few hours after launch due to overheating caused by problems with the spacecraft. Her journey remains a reminder of both the incredible achievements and difficult ethical questions surrounding early space exploration. Laika had traveled farther than any living creature before her. She had become the first animal to orbit Earth. Her mission provided valuable scientific information that helped future human spaceflight. But it also raised questions that scientists and societies would continue to consider as exploration moved forward. What risks were acceptable in the pursuit of discovery? How should humans balance curiosity with responsibility? These questions would follow the space race throughout its history. While the Soviet Union focused heavily on orbital missions, American scientists continued their own research. The United States developed programs to test whether humans could survive the conditions of spaceflight. One important project was Project Mercury, NASA's first human spaceflight program. But before astronauts would fly, scientists needed additional confidence that living beings could withstand the journey. More animal missions followed. Monkeys, mice, and other creatures helped researchers understand the effects of weightlessness, radiation exposure, and high-speed travel. Each mission answered a few more questions. Each experiment reduced some of the uncertainty. Slowly, the impossible began to feel achievable. The idea of a human traveling into space was no longer just a dream. The technology was advancing. The rockets were becoming more reliable. The knowledge was growing. And somewhere, future astronauts were beginning their own preparations for the greatest journey in human history. The first travelers beyond Earth were not famous astronauts. They were small creatures carried into the unknown before anyone knew exactly what they would experience. They were the quiet pioneers who crossed the boundary between Earth and space. Their journeys helped reveal the path forward. Because before humans could reach the stars, others had to go first. And soon, after years of preparation and countless experiments, a human voice would finally travel from above the clouds. The age of human spaceflight was about to begin. For thousands of years, humanity had looked toward the sky and wondered what existed beyond the clouds. Ancient civilizations tracked the movements of the stars. Scientists calculated the paths of planets. Dreamers imagined journeys to the moon. But no human being had ever left the surface of Earth. The planet had always been our home, our boundary, and our entire world. Then, in the spring of 1961, everything changed. A single person climbed into a small spacecraft, sat above a powerful rocket, and prepared to become the first human to travel into space. His name was Yuri Gagarin, and his journey would forever change how humanity understood its place in the universe. The achievement did not happen suddenly. It was the result of decades of scientific curiosity, years of engineering work, and countless experiments with rockets, instruments, and animals. The Soviet Union had been moving quickly in the space race. After the success of Sputnik and the early animal missions, Soviet engineers began preparing for the next great milestone, sending a person into orbit. The challenge was enormous. A human spacecraft needed to do more than simply reach space. It had to keep a person alive in an environment where humans had never survived before. Scientists needed to understand how the body would respond to weightlessness. They needed reliable communication systems. They needed a spacecraft that could withstand the intense heat of returning through Earth's atmosphere. And they needed a person brave enough to climb inside. The Soviet program selected a group of military pilots to become the first cosmonauts. These men underwent intense training designed to prepare them for conditions unlike anything they had experienced. They practiced surviving extreme forces. They trained inside spinning centrifuges that simulated the pressure of launch. They learned how to operate spacecraft systems. They prepared for emergencies in case something went wrong. Among these candidates was Yuri Gagarin. Born in 1934 in a small village west of Moscow, Gagarin came from a modest background. His early life was shaped by the hardships of World War II and the challenges faced by many Soviet families. As a young man, he became interested in aviation and eventually trained as a pilot. His calm personality, intelligence, and ability to remain composed under pressure made him an ideal candidate for the historic mission. He was not chosen because he was the strongest or most experienced pilot. He was chosen because he had the qualities needed for a journey into the unknown. On April 12, 1961, the spacecraft Vostok 1 stood ready at the launch site in Kazakhstan. The spacecraft itself was small and simple compared to modern vehicles. Inside was a small cabin designed to protect one person during the journey. Gagarin sat strapped into his seat, waiting as the countdown approached. Outside, engineers and technicians prepared the rocket. Years of work had led to this moment. Every calculation, every test, every previous mission, all of it had led here. Then the engines ignited. The rocket began to rise. Gagarin became the first human being to leave Earth. The powerful machine carried him upward, beyond the atmosphere, into the darkness of space. As the spacecraft reached orbit, Gagarin looked down at the planet below. For the first time in history, a human being was seeing Earth from above. The view was unlike anything anyone had ever witnessed. The curved horizon, the thin layer of atmosphere, the vastness of the world below. The planet that had always seemed enormous now appeared as a single, connected place. During the flight, Gagarin orbited Earth once. The entire mission lasted only 108 minutes. But those minutes represented one of the greatest achievements in human history. A person had traveled beyond the limits that had separated humanity from space for all of time. Gagarin's mission was not only a scientific accomplishment. It was a powerful symbol. The Soviet Union had achieved another major victory in the space race. News of the mission spread around the world. People celebrated the achievement. Governments recognized its significance. The first human had entered orbit, and the future suddenly seemed much larger. Gagarin became an international celebrity. He traveled around the world, visiting different countries and meeting people who wanted to see the first person who had traveled beyond Earth. But beneath the celebrations was a deeper meaning. Gagarin's flight demonstrated something fundamental about humanity. We were no longer limited to the surface of our planet. The boundary between Earth and space had been crossed. The universe was no longer something we could only observe. It was somewhere we could go. The success of Vostok 1 also created a new sense of urgency in the United States. American leaders understood that the Soviet Union had achieved another major milestone, and the pressure to catch up grew stronger. The United States had already created NASA and begun preparing its own human spaceflight program. Now, the goal was clear. America needed to send its own astronauts into space. But the challenge was not only reaching orbit. The next question was even greater. Could humans travel farther? Could they spend more time in space? Could they eventually reach the moon? The space race was entering a new phase. The early years had been about proving that machines could survive beyond Earth. Now it was about proving that humans could. The first human journey into space had lasted less than 2 hours. But its impact would last forever. Yuri Gagarin's spacecraft had circled Earth only once, but that single orbit changed the course of history. For the first time, someone had looked down on our world from the darkness above. And when he returned, humanity had gained something that could never be taken away. The knowledge that we could leave home. The sky was no longer the limit. It was the beginning. The first human journey into space had lasted only a short time. Just 108 minutes. But those minutes changed the direction of history. When Yuri Gagarin returned safely to Earth after becoming the first person to orbit the planet, the world understood that the space age had entered a new chapter. The question was no longer whether humans could reach space. They could. The question was whether other nations could follow. For the United States, the answer needed to come quickly. The space race had become a competition not only of technology, but of determination, imagination, and national pride. The United States had already created NASA and begun preparing for human spaceflight. Now the agency faced its first great challenge: sending an American astronaut beyond Earth. The program that would accomplish this goal was called Project Mercury. Unlike later missions that would send astronauts into orbit for days or travel all the way to the moon, Project Mercury had a simple but ambitious purpose: to learn whether humans could survive in space. The scientists and engineers working on the program knew they were entering unfamiliar territory. Every decision involved questions that had never been answered. How would the human body react to weightlessness? Could astronauts communicate while traveling at incredible speeds? Would a spacecraft designed by humans be reliable enough to bring them home? The answers could only be discovered through experience. And that meant someone had to be willing to take the journey. In April 1959, NASA introduced a group of 7 military test pilots who would become the first American astronauts. They became known as the Mercury 7. The group included Alan Shepard, Gus Grissom, John Glenn, Scott Carpenter, Wally Schirra, Gordon Cooper, and Deke Slayton. Each man brought years of aviation experience and a calm ability to handle intense situations. They were not chosen because they wanted fame. They were chosen because they had the skills needed for a mission where failure could have deadly consequences. The astronauts quickly became symbols of the new space program. They appeared in magazines, attended public events, and represented the hopes of a nation eager to prove itself. But behind the public image was a demanding training program. The Mercury astronauts faced challenges unlike any pilots had experienced before. They spent hours inside simulators learning how to control their spacecraft. They trained in high-speed aircraft to experience extreme forces. They practiced surviving in isolated environments. They studied engineering, medicine, and spacecraft systems. They even participated in unusual experiments designed to prepare them for the unknown. The goal was simple. When they left Earth, they needed to be ready for anything. The spacecraft they would fly was called Mercury. Compared to later spacecraft, it was incredibly small. The capsule was barely large enough for one astronaut to sit inside. The astronaut would not be flying the spacecraft like an airplane. Instead, Mercury was designed to be controlled mostly by automated systems, with the astronaut monitoring conditions and making adjustments when necessary. The first American human spaceflight came on May 5, 1961. Astronaut Alan Shepard climbed into the spacecraft named Freedom 7. Unlike Gagarin's mission, Shepard's flight would not complete an orbit around Earth. Instead, it was a suborbital flight, meaning the spacecraft would travel into space and then return without circling the planet. The mission lasted just over 15 minutes. But those minutes were historic. As the rocket lifted from the launch pad at Cape Canaveral, Shepard became the first American in space. The experience was intense. The rocket shook violently during launch. The forces pressed against his body. Then, suddenly, everything became quiet. Shepard reached space. For a brief moment, he floated above Earth, experiencing the strange sensation of weightlessness. Looking through the spacecraft window, he saw something no American had ever seen before. The curve of the Earth, the darkness of space, the thin blue line of the atmosphere. Then came the journey home. The spacecraft re-entered Earth's atmosphere, protected by its heat shield, and splashed down safely in the Atlantic Ocean. America had reached space. The achievement was celebrated across the nation. But the space race continued. Only a few weeks later, President John F. Kennedy would announce a goal that seemed almost impossible. Before the end of the decade, America would land a human being on the moon. Before that could happen, NASA needed to learn even more. Astronauts needed to spend longer periods in space. Spacecraft needed to become more advanced. Engineers needed to solve problems that had never been encountered before. The next Mercury missions continued building this knowledge. On February 20th, 1962, John Glenn became the first American to orbit Earth. His mission, aboard Friendship 7, was one of the most important moments in American space history. Glenn completed 3 orbits around the planet, spending nearly 5 hours in space. For many Americans, his journey represented a turning point. The United States was no longer simply trying to catch up. It was becoming a serious competitor in the race beyond Earth. During his flight, Glenn experienced both excitement and uncertainty. A warning indicated a possible issue with his spacecraft's heat shield, creating concern about whether he would survive re-entry. The decision was made to carefully monitor the situation and take precautions. After completing his orbits, Glenn returned safely to Earth. The mission was a success. The nation celebrated. The Mercury program had accomplished its purpose. It had proven that humans could travel into space, operate spacecraft, and return safely to Earth. But the lessons learned from Mercury were only the beginning. Space exploration was moving faster than ever. The United States and Soviet Union were no longer simply trying to reach orbit. They were looking farther ahead. The ultimate destination was now becoming clear. The moon. The first astronauts had opened the door. They had crossed the invisible boundary between Earth and space and shown that humans belonged among the stars. But the journey ahead would be far more difficult. The next steps would require longer flights, more advanced technology, and a level of determination unlike anything before. The space race was accelerating, and humanity was preparing for its greatest adventure yet. In the early years of the space race, reaching space itself was the greatest challenge. The first satellite, the first animal, the first human in orbit. Each achievement pushed the boundaries of what people believed was possible. But after the Soviet Union sent Yuri Gagarin into orbit and the United States followed with its own astronauts, a new question emerged. What was the next destination? The answer would change the course of human history. The moon. For centuries, the moon had been a symbol of mystery and imagination. It had inspired poets, scientists, and dreamers. It had been observed through telescopes and studied from Earth, but it remained untouched by human hands. Now, for the first time, reaching it seemed like a possibility. The challenge was enormous. The moon was nearly 250,000 miles away. A spacecraft would need to travel through the emptiness of space, enter lunar orbit, land on the surface, and return safely to Earth. No nation had ever attempted anything close to this. It would require new rockets, new spacecraft, new methods of navigation, and thousands of people working together toward one extraordinary goal. The decision to pursue the moon was not made only because of science. It was also shaped by the intense competition of the Cold War. The United States had fallen behind the Soviet Union in several early milestones of space exploration. Sputnik had shocked Americans. Gagarin's flight had created another moment of Soviet success. American leaders understood that space achievements had become powerful symbols around the world. A nation that reached the moon would demonstrate not only scientific ability, but also technological strength. In May 1961, President John F. Kennedy addressed Congress and announced one of the most ambitious goals in human history. The United States, he declared, would send a man to the moon and return him safely to Earth before the end of the decade. The announcement was bold. At the time, the United States had only recently sent its first astronaut into space. NASA had limited experience with human spaceflight. The technology required for a lunar mission did not yet exist. The rockets needed to carry astronauts to the moon had not been built. The spacecraft had not been designed. Many of the problems had not even been identified. Yet the goal had been set. The moon was no longer just a dream. It was a destination. Behind this enormous mission was an organization that would soon grow into one of the largest scientific and engineering efforts in history.
NASA.
The agency would coordinate the work of hundreds of thousands of people across the United States. Engineers, scientists, manufacturers, mathematicians, and technicians would all contribute to the effort. The journey to the moon would not belong to one person. It would belong to an entire generation. The first challenge was developing the technology needed for such a journey. A rocket capable of reaching the moon would need to be far more powerful than anything built before. The spacecraft would need to support astronauts for days in space. Navigation systems would need to guide them across hundreds of thousands of miles. And every part of the mission would need to work perfectly. There was no room for mistakes. NASA began creating a series of programs designed to build knowledge step by step. The Mercury program had shown that humans could survive short journeys into space. The next program would teach astronauts how to live and work there for longer periods. It was called Gemini. Before astronauts could travel to the moon, they needed to learn the skills required for a lunar mission. They needed to practice docking spacecraft together. They needed to understand how to operate outside their spacecraft during spacewalks. They needed to learn how long humans could survive in orbit. Every mission became a lesson. Every flight revealed something new. But while NASA was preparing for future missions, the Soviet Union continued its own efforts. The space race remained a competition. Each achievement by one nation created pressure for the other to respond. Both sides wanted to prove that their technology and their system could accomplish what the other could not. The moon became the ultimate prize. For the Soviet Union, reaching the moon would continue the momentum created by Sputnik and Gagarin. For the United States, it represented a chance to demonstrate that it could accomplish something extraordinary. But beyond the competition, there was something deeply human about the goal. The moon was the closest world beyond Earth. It hung in the night sky, familiar and mysterious at the same time. Every person who had ever looked upward had seen it. Children had pointed at it. Families had watched it rise. Ancient civilizations had built calendars around it. Now humans were preparing to visit. The idea seemed almost impossible. A person walking on another world. Footprints in lunar dust. A human voice traveling from the surface of the moon back to Earth. Yet impossible dreams had always been part of exploration. The first sailors who crossed unknown oceans did not know what they would find. The first pilots who built airplanes did not know exactly where flight would lead. And now, the first astronauts were preparing to leave Earth's orbit and travel farther than any human being ever had before. The path would not be easy. There would be failures. There would be setbacks. There would be moments when the dream seemed too difficult to achieve. But every great journey begins with a decision to try. The moon race had begun. Across the United States, engineers worked late into the night. Factories produced new spacecraft components. Scientists calculated impossible-looking trajectories. Astronauts trained for missions that had never been attempted. The world watched as humanity prepared to take its next great step. The first humans had reached space. Now they were preparing to reach another world. And above Earth, quietly shining in the darkness, the moon waited. The moon was waiting. But before humans could walk across its surface, they first needed to learn how to survive the journey. A trip to the moon was not simply a longer version of traveling into orbit. It was an entirely new challenge. Astronauts would need to spend many days away from Earth. They would need to operate complex machines, navigate through space, connect spacecraft together, and work in an environment where a simple mistake could become dangerous. The Mercury program had proven that humans could reach space and return safely. But Mercury had only answered the first questions. Could people survive launch? Could they endure weightlessness? Could spacecraft protect them during the journey home? The next challenge was much greater. Could humans live and work in space long enough to travel to another world? To answer that question, NASA created a new program called Gemini. Named after the constellation representing twins, Project Gemini was designed as the bridge between early spaceflight and the eventual journey to the moon. The missions would not land anywhere new. They would not carry astronauts across the vast distance between Earth and the moon. Instead, Gemini would teach NASA the skills required to make that journey possible. The program focused on several important goals. Astronauts needed to learn how to remain in space for longer periods. They needed to practice changing their spacecraft's orbit. They needed to master rendezvous and docking, the process of bringing two spacecraft together in orbit. And they needed to learn how to work outside the spacecraft during spacewalks. Every one of these skills would become essential for a lunar mission. The spacecraft itself was an improvement over Mercury. While Mercury carried only one astronaut, Gemini could hold two. The larger cabin gave astronauts more room to work, and the spacecraft included more advanced systems that allowed greater control during flight. But even with improved technology, space remained a dangerous and unfamiliar environment. The astronauts selected for Gemini missions were some of the most experienced and talented pilots in the world. Many had military backgrounds and had spent years preparing for the challenges ahead. Among them were future Apollo astronauts who would eventually become famous names in space history. The Gemini program began in 1965. The early missions focused on testing the spacecraft and proving that its systems worked. But soon, astronauts began attempting tasks that had never been performed before. One of the most important achievements came when astronauts learned how to maneuver spacecraft in orbit. On Earth, pilots could rely on familiar surroundings. In space, there were no roads, no landmarks, and no obvious sense of direction. Moving a spacecraft required careful calculations and precise control. The astronauts had to learn a new kind of flying. One of the greatest challenges was learning how to dock two spacecraft together. For future moon missions, astronauts would need to transfer between spacecraft while traveling through space. The Apollo spacecraft would eventually use this technique when astronauts moved between the command module and lunar module. Gemini missions practiced this essential skill. Slowly, NASA was learning how to build a pathway to the moon. But perhaps the most dramatic new experience came when astronauts stepped outside their spacecraft. Spacewalking, known officially as extravehicular activity, allowed humans to experience space directly. The first American spacewalk was performed by astronaut Edward White during the Gemini 4 mission in June 1965. As he opened the spacecraft hatch and floated into the darkness, White became the first American to leave the protection of his spacecraft. The moment was both exciting and surreal. Connected only by a thin tether, he floated above Earth while traveling at incredible speed. Below him, continents and oceans moved silently across the planet. Above him was the endless darkness of space. White later described the experience as one of the most remarkable moments of his life. But spacewalking also revealed new challenges. Astronauts discovered that working in space was much harder than expected. Simple movements required effort. Tools behaved differently. The human body responded differently without normal gravity. Every experience provided information that would help future explorers. The Gemini program also demonstrated how humans could spend longer periods away from Earth. In 1965, Gemini 5 stayed in orbit for nearly 8 days, showing that astronauts could survive missions approaching the length needed for a moon journey. Later missions extended this even further. The record-breaking Gemini 7 mission lasted nearly 2 weeks. Astronauts Frank Borman and Jim Lovell spent 14 days in orbit, studying how the human body handled extended time in space. The mission showed that humans could endure the long journey ahead. By the end of Gemini, NASA had accomplished something extraordinary. The agency had learned how to live in space. Astronauts had flown farther, stayed longer, performed spacewalks, and practiced the complex movements needed for future missions. The path to the moon was becoming clearer. But progress did not come without difficulties. The space race remained a dangerous competition. The Soviet Union continued developing its own lunar ambitions, and both nations pushed forward under enormous pressure. Every mission carried risks. Every launch required courage. The astronauts understood that they were not simply participating in a scientific experiment. They were exploring a place where humans had never been. They were moving farther from Earth than anyone in history. And yet, despite the dangers, the dream continued. The moon grew closer. The technology improved. The knowledge expanded. Thousands of people worked behind the scenes, turning impossible ideas into reality. By the middle of the 1960s, the United States had built a foundation for its greatest adventure. The rockets were becoming more powerful. The spacecraft were becoming more advanced. The astronauts were becoming more prepared. The lessons of Mercury and Gemini had brought humanity to the edge of a new frontier. Soon, people would travel farther than Earth's orbit. Soon, astronauts would leave Earth's neighborhood and journey toward another world. The moon was no longer just a distant light in the night sky. It was becoming a place humans could reach. And the next chapter of the space race would bring humanity closer than ever before. While the United States was building the path toward the moon through Mercury, Gemini, and the early Apollo missions, the Soviet Union was quietly pursuing its own lunar ambitions. To much of the world, the Soviet space program appeared unstoppable. It had launched the first artificial satellite. It had sent the first living creature into orbit. It had placed the first human being into space. Each achievement had created a wave of excitement and demonstrated the strength of Soviet science and engineering. But behind the public celebrations was a much more complicated story. The race to the moon was not only a competition of achievements. It was a competition of secrecy, pressure, and determination. The Soviet Union wanted to accomplish what no nation had ever done. It wanted to send a person to the moon before the United States. At the center of the Soviet space program was a brilliant engineer named Sergei Korolev. For years, Korolev had guided Soviet achievements in space exploration. He had overseen the development of the rockets that launched Sputnik and carried Yuri Gagarin into orbit. To the outside world, however, his identity remained unknown. The Soviet government kept his name secret, referring to him simply as the chief designer. This secrecy reflected the nature of the Soviet space program. While NASA openly shared many details about its missions, the Soviet Union kept much of its work hidden from the public. Successes were celebrated. Failures were often concealed. Behind closed doors, Soviet engineers faced the enormous challenge of designing a spacecraft capable of reaching the moon. The mission would require a completely new approach. A lunar journey was far more difficult than reaching Earth orbit. A spacecraft would need to travel hundreds of thousands of miles through space, enter orbit around another world, and safely return. The rocket carrying the spacecraft would need extraordinary power. The Soviet Union began developing a massive launch vehicle called the N-1. Designed to compete with America's Saturn V rocket, the N-1 was intended to carry Soviet cosmonauts toward the moon. The rocket was enormous. It stood over 300 feet tall and contained dozens of powerful engines working together. Building such a machine was an incredible engineering challenge. The technology needed for a moon mission pushed the limits of what engineers knew how to accomplish. Every part had to function perfectly. Every engine needed to ignite at the same time. Every system had to work together. The slightest failure could destroy the entire mission. At the same time, Soviet engineers were developing a spacecraft for the journey itself. The lunar spacecraft, known as the Soyuz, was designed to carry cosmonauts around Earth and eventually support missions beyond orbit. A separate vehicle, the lunar module, would allow astronauts to descend to the moon's surface and return to orbit. Like the American Apollo program, the Soviet lunar plan required complex teamwork between multiple spacecraft. But the Soviet program faced challenges beyond engineering. In 1966, Sergei Korolev died unexpectedly during a medical operation. His death was a major loss for the Soviet space effort. He had been the guiding force behind many of the nation's greatest achievements in space. Without his leadership, the program struggled to maintain the same direction and momentum. The Soviet Union continued its efforts, but the pressure increased. The United States was moving closer to its own moon landing. NASA was developing the Saturn V rocket. Apollo missions were advancing. The deadline announced by President Kennedy was approaching. The Soviet Union could not afford to fall behind. But the race was not simply about technology. It was also about politics. The leaders of both nations understood the symbolic importance of reaching the moon. The first country to land humans there would demonstrate a remarkable level of scientific and technological ability. It would show the world what its system could accomplish. The pressure on Soviet engineers was immense. They were working with limited time and enormous expectations. Many of their efforts remained hidden from the public, even within the Soviet Union itself. Unlike NASA astronauts, Soviet cosmonauts did not always know the full details of their missions until shortly before launch. This secrecy created additional difficulties. Communication between teams was complicated. Mistakes were harder to address openly. Lessons from failures were sometimes difficult to share. Still, Soviet engineers continued pushing forward. Their achievements in robotic lunar exploration were impressive. The Soviet Union successfully sent unmanned spacecraft to the moon, including missions that photographed the lunar surface, studied its environment, and eventually returned samples of lunar soil to Earth. These missions demonstrated remarkable technical skill. They showed that the Soviet Union remained a powerful force in space exploration. But the ultimate goal was still a human landing. And that goal remained just out of reach. As the 1960s continued, the two nations moved closer to the moment that would define the space race. The United States was preparing for Apollo. The Soviet Union was preparing its own lunar missions. Both were aiming for the same destination, the moon. From Earth, the moon looked peaceful and unchanged. It rose above oceans and mountains. It illuminated quiet nights. It inspired wonder across generations. But behind the scenes, thousands of people were working tirelessly to reach it. Scientists calculated trajectories. Engineers tested machines. Astronauts and cosmonauts trained for journeys beyond anything humanity had attempted. The competition was intense. The risks were real. And neither nation knew exactly who would succeed. The Soviet Union had started the space race with a series of historic firsts. But reaching the moon would require something even greater. It would require flawless execution of the most complicated mission ever attempted. As the decade approached its final years, the race entered its most dramatic stage. The rockets were ready. The astronauts were preparing. And the moon waited above both nations, silent and distant. The next steps would determine who would leave the first footprints on another world. By the middle of the 1960s, the dream of reaching the moon had become more than an idea. It had become a mission. Across the United States, thousands of engineers, scientists, technicians, and astronauts were working toward a single goal: landing humans on the lunar surface before the end of the decade. The progress was remarkable. Mercury had proven that humans could survive spaceflight. Gemini had taught astronauts how to work in orbit, perform spacewalks, and maneuver spacecraft. The path to the moon was becoming clearer. But as the Apollo program moved forward, the dangers of space exploration became impossible to ignore. The journey ahead would require enormous courage. And before humanity could take its greatest step beyond Earth, the Apollo program would face one of its darkest moments. The mission was called Apollo 1. It was intended to be the first crewed flight of the Apollo spacecraft, a crucial test before future missions would travel farther into space. The astronauts chosen for the mission were 3 experienced and respected members of NASA's astronaut corps: Virgil Gus Grissom, Edward White, and Roger Chaffee. Each represented a different stage of America's journey into space. Gus Grissom had been one of the original Mercury 7 astronauts. He had already flown in space twice, becoming one of the most experienced American astronauts of his time. Ed White had made history during the Gemini 4 mission by becoming the first American to perform a spacewalk. Roger Chaffee was a newer astronaut, preparing for his first journey beyond Earth. Together, they represented the future of the Apollo program. Their mission would test the spacecraft systems needed for the journeys ahead. But the spacecraft was still being developed. Apollo was far more complex than anything NASA had built before. Unlike Mercury and Gemini capsules, the Apollo Command Module needed to carry astronauts on much longer missions. It had to support a crew for days in space. It had to communicate over enormous distances. And it had to survive the intense heat of returning from the moon. Every component had to be reliable. Every system had to be carefully tested. The spacecraft was undergoing improvements, but problems remained. On January 27, 1967, the Apollo 1 crew entered the command module for a routine test at the Kennedy Space Center in Florida. The test was not a launch. The rocket was not fueled. The spacecraft remained on the ground. But the astronauts were performing a full rehearsal, wearing their spacesuits and practicing procedures as if they were preparing for flight. Inside the spacecraft, they communicated with mission controllers. The atmosphere was serious but routine. Then suddenly something went wrong. A fire began inside the cabin. Because the spacecraft was filled with pure oxygen at higher pressure than normal atmospheric conditions, the fire spread rapidly. Within seconds, the situation became catastrophic. The astronauts attempted to respond, but the spacecraft's hatch design made escape extremely difficult. The crew could not get out in time. The fire claimed the lives of Gus Grissom, Ed White, and Roger Chaffee. The loss shocked NASA and the entire nation. The Apollo program had suffered its first crewed mission tragedy. For a program built around exploration and optimism, it was a heartbreaking reminder of the risks involved. The astronauts were not simply names on a mission patch. They were people. They had families. They had dreams. They had dedicated their lives to exploring the unknown. Their deaths were mourned across the country and within the space community around the world. But their sacrifice also led to major changes. NASA immediately began investigating what had happened. Engineers carefully examined every detail of the spacecraft design. They discovered problems that needed to be corrected before humans could safely continue toward the moon. The Apollo Command Module was redesigned. The cabin environment was changed. Materials were improved. The hatch was modified so astronauts could escape quickly in an emergency. Safety procedures were strengthened throughout NASA. The tragedy forced the agency to slow down and examine its methods. The goal of reaching the moon remained, but now it carried an even greater responsibility. The astronauts who flew future missions would depend on the lessons learned from Apollo 1. The loss of the crew became part of the foundation upon which later successes were built. In the years that followed, NASA honored the Apollo 1 astronauts by carrying their memory forward. Their names became permanently connected with the journey to the moon. They were pioneers who gave their lives while preparing the way for others. The space race was often described through moments of triumph. The first satellite, the first human in space, the first moon landing. But exploration has always included moments of difficulty and loss. Every great achievement carries risk. Every step into the unknown requires people willing to face uncertainty. The tragedy of Apollo 1 reminded the world that space was not a place to be conquered easily. It demanded respect. It demanded preparation. It demanded humility. As NASA recovered from the loss, the Apollo program continued. The dream of reaching the moon remained alive. The lessons learned from Apollo 1 would make future missions safer and stronger. Engineers returned to their work. Astronauts continued training. The spacecraft was rebuilt. Slowly, carefully, the program moved forward. The moon was still waiting. But before humans could walk upon its surface, they first had to overcome the challenges standing in their way. The path to the moon would not be a straight line. It would be filled with moments of excitement and moments of heartbreak. It would require courage not only when things went right, but also when they went wrong. And from the tragedy of Apollo 1 came a renewed determination. The dream would continue. The journey would continue. Because the goal was still there, shining quietly above Earth. A distant world waiting for human footsteps. By the end of the 1960s, the space race had reached a critical moment. The United States had experienced incredible achievements, but it had also endured painful setbacks. The tragedy of Apollo 1 had forced NASA to reconsider every detail of its spacecraft and procedures. The dream of reaching the moon remained. But before astronauts could land there, they needed to take another step. They needed to leave Earth's orbit completely. For the first time in history, humans would travel farther than anyone had ever traveled before. They would journey into the space between worlds. The mission that would make this possible was Apollo 8. It was a mission unlike any that had come before. Previous human spaceflights had remained close to Earth, orbiting the planet and studying the effects of space on the human body. Apollo 8 would go somewhere entirely different. It would travel to the moon. The mission would not land astronauts on the lunar surface. Instead, it would send them around the moon and return them safely to Earth. It was a bold and risky decision. The spacecraft had never carried humans that far. The journey would take astronauts beyond the protective familiarity of Earth's orbit and into the vast darkness of deep space. For the first time, the only planet humans had ever known would become a distant object behind them. The crew selected for Apollo 8 consisted of 3 astronauts: Frank Borman, James Lovell, and William Anders. Each brought experience and skill to the mission. Frank Borman served as commander. He was known as a disciplined leader who approached challenges with careful attention and focus. James Lovell served as command module pilot. He had already flown in space during the Gemini program and understood the challenges of long-duration missions. William Anders served as lunar module pilot. Although Apollo 8 would not carry a lunar module to the moon's surface, his role was still essential in operating and monitoring the spacecraft systems. Together, they prepared for a journey unlike anything humans had attempted. The Apollo spacecraft consisted of the command module and service module, carried into space by the enormous Saturn V rocket. The Saturn V was one of the most powerful machines ever built. Standing over 360 feet tall, it represented years of engineering and innovation. When fully assembled, it towered above the launch complex, a massive symbol of human ambition. On December 21, 1968, Apollo 8 launched from Kennedy Space Center. The countdown reached 0. The engines ignited, and the Saturn V lifted the spacecraft away from Earth. The vibration was intense. The power was enormous. Thousands of people watched as the rocket climbed into the sky, carrying 3 humans toward the moon. After reaching Earth orbit, Apollo 8 began the next stage of its journey. The spacecraft's engines fired, sending it onto a path toward the moon. This maneuver, known as translunar injection, changed everything. For the first time, humans were no longer simply circling Earth. They were leaving. As Apollo 8 traveled through deep space, the astronauts experienced a perspective no human had ever known. Earth grew smaller behind them. The familiar planet became a distant blue sphere surrounded by darkness. The journey was quiet. Inside the spacecraft, the astronauts monitored systems, performed experiments, and prepared for their arrival at the moon. Outside their windows was the endless emptiness of space. Then, after several days of travel, they reached their destination, the moon. Apollo 8 entered lunar orbit on December 24, 1968. For the first time, humans were circling another world. The astronauts looked down upon the lunar surface, seeing mountains, craters, and vast plains that had previously only been observed through telescopes. The moon, which had always appeared so familiar from Earth, now revealed itself as a real place. A place humans had reached. But perhaps the most memorable moment of the mission came when the astronauts looked away from the moon and back toward home. During one orbit, they saw something extraordinary. Rising above the lunar horizon was Earth, a small blue and white sphere floating against the darkness of space. The astronauts captured the moment in a photograph that became one of the most famous images in human history. It was called Earthrise. The image showed our planet in a way no one had ever seen before. Earth was not a vast and endless world. From the distance of the moon, it appeared small, fragile, and beautiful. The photograph changed the way many people thought about our planet. It showed a world without visible borders, a single home shared by everyone. The astronauts also sent a Christmas Eve message back to Earth while orbiting the moon. Millions of people around the world listened as their voices traveled across space. They spoke about the beauty of the Earth and read passages from the Book of Genesis. For many listeners, it became a peaceful and emotional moment during a difficult period in world history. In 1968, the world was experiencing conflict, uncertainty, and division. But on Christmas Eve, 3 astronauts floating around the moon offered something different. A reminder of our shared humanity. After completing 10 orbits around the moon, Apollo 8 began its journey home. The spacecraft successfully returned to Earth, splashing down in the Pacific Ocean on December 27th. The mission was a complete success. Apollo 8 had accomplished something extraordinary. Humans had traveled to another world. They had escaped Earth's orbit. They had seen the far side of the moon. And they had looked back at their own planet from a distance. The mission proved that the technology needed for a moon landing was possible. The next step was clear: landing on the lunar surface. Apollo 8 had brought humanity closer than ever before. The moon was no longer just a destination in the future. It was a place humans had visited, a place they had traveled to and returned from. The impossible was becoming reality. And above Earth, quietly glowing in the night sky, the moon waited for the next visitors. Soon, humans would not only orbit another world. Soon, they would stand upon it. The moon was closer than ever before. After years of imagination, planning, and extraordinary effort, humanity had reached a moment that once seemed impossible. A spacecraft had traveled to another world. Astronauts had orbited the moon. A photograph of Earth rising above the lunar surface had changed the way people viewed their own planet. Apollo 8 had proven that humans could journey beyond Earth's orbit. But reaching the moon was only part of the challenge. The hardest part still remained: landing. A journey to the lunar surface required more than simply flying to the moon and returning home. Astronauts would need to perform one of the most complicated maneuvers ever attempted. They would need to separate from their spacecraft while orbiting another world. They would need to descend to the surface in a small vehicle never tested on the moon. They would need to launch again from the lunar surface and reconnect with the spacecraft waiting above. Every step had to work perfectly. There was no room for error. Before attempting the first landing, NASA needed to complete the final tests. The next missions would serve as rehearsals. They would prove that the spacecraft, astronauts, and mission procedures were ready. The first of these missions was Apollo 9. Launched on March 3, 1969, Apollo 9 was designed to test the spacecraft systems needed for a lunar landing while remaining in Earth orbit. The crew included Commander James McDivitt, Command Module Pilot David Scott, and Lunar Module Pilot Rusty Schweikart. Their mission focused on the most important new piece of technology in the Apollo program, the Lunar Module. Unlike previous spacecraft, the Lunar Module was designed specifically to operate in the Moon's environment. It would carry astronauts from lunar orbit down to the surface and then return them to the Command Module. It was a remarkable machine, but it was also unlike anything ever built. The Lunar Module did not need to fly through Earth's atmosphere. It did not need the streamlined shape of an airplane. Instead, it was designed purely for space. With thin walls, landing legs, and exposed components, it looked almost fragile compared to the powerful rockets and spacecraft surrounding it. But every part had a purpose. Apollo 9 was the first time astronauts tested the lunar module in space. The crew practiced separating the two spacecraft, flying independently and reconnecting afterward. They tested engines. They tested navigation systems. They practiced the procedures that would eventually be used near the Moon. One of the mission's most important moments came when astronaut Rusty Schweikart performed a spacewalk. The goal was to test the techniques astronauts would need if they ever had to move between spacecraft while wearing spacesuits. Floating outside the spacecraft, Schweikart experienced the silence and beauty of space firsthand. Below him was Earth. Above him was the endless darkness. The mission demonstrated that the lunar module was ready. The next step was even more ambitious.
Apollo 10.
If Apollo 9 was a test of the equipment, Apollo 10 would be the final complete rehearsal before the Moon landing. The crew included Commander Thomas Stafford, Command Module Pilot John Young, and Lunar Module Pilot Eugene Cernan. Their mission would take them all the way to lunar orbit. They would travel to the Moon. They would separate the lunar module, and they would descend close to the surface. But they would not land. Apollo 10 launched on May 18, 1969. Once again, the massive Saturn V rocket carried humans beyond Earth. The spacecraft traveled toward the Moon, continuing the path created by Apollo 8. When Apollo 10 reached lunar orbit, the astronauts prepared for the most important part of the mission. The lunar module, nicknamed Snoopy, separated from the Command Module. For the first time, a lunar module operated near the Moon. Stafford and Cernan descended toward the lunar surface, while John Young remained in orbit above them. They came within just a few miles of the Moon. Below them was the destination humans had dreamed about for generations. The lunar landscape stretched out beneath their spacecraft. Mountains, craters, endless gray plains. The Moon was no longer just something viewed through telescopes. It was a real place waiting below. During the descent, the astronauts practiced every step of the landing process. They tested navigation. They evaluated the spacecraft's performance. They gathered information that would help the next mission. But they had to stop short of the surface. The mission plan required them to return to lunar orbit and reconnect with the Command Module. It was one of the most delicate operations ever attempted. The lunar module successfully reunited with the Command Module. The astronauts began their journey home. Apollo 10 was a complete success. NASA had now tested nearly every part of the lunar landing mission. The rocket worked. The spacecraft worked. The astronauts had proven they could perform the necessary procedures. The path was clear. One final mission remained. Apollo 11, the mission that would attempt what no human had ever done. Landing on another world. The journey from Earth to the Moon had taken generations of imagination and decades of scientific progress. It had begun with early dreamers who looked at the sky and wondered. It had continued through scientists who studied rockets and engineers who built machines capable of leaving Earth. It had survived setbacks, failures, and tragedy. Now, after years of preparation, humanity stood on the edge of its greatest adventure. The world watched. The astronauts trained. The spacecraft waited. The Moon remained silent above Earth. And soon, for the first time, human footsteps would touch its surface. For thousands of years, humanity had looked toward the Moon. It had guided travelers across oceans. It had inspired stories and legends. It had been painted, studied, and observed by generations of people standing beneath the night sky. But no one had ever touched it. The Moon remained a distant world, close enough to see, but impossibly far away. Until the summer of 1969. After years of planning, testing, successes, and tragedies, the moment had finally arrived. Humanity was ready to leave footprints on another world. The mission was called Apollo 11. Its goal was simple to describe, but incredibly difficult to accomplish. Land humans on the moon and return them safely to Earth. Behind those words were years of work from hundreds of thousands of people. Engineers had designed the spacecraft. Scientists had calculated the journey. Technicians had assembled the machines. Astronauts had trained for the dangers ahead. Everyone involved understood the importance of the mission. This was not simply another space flight. This was the moment the space race had been building toward. The crew chosen for Apollo 11 included 3 astronauts: Neil Armstrong, Buzz Aldrin, and Michael Collins. Neil Armstrong served as commander of the mission. A quiet and thoughtful test pilot, Armstrong had already flown in space during the Gemini program. He was known for his calm personality and ability to remain focused under pressure. Buzz Aldrin served as lunar module pilot. A skilled engineer and astronaut, Aldrin had studied orbital mechanics and contributed greatly to understanding how spacecraft could meet and connect in space. Michael Collins served as command module pilot. While Armstrong and Aldrin would descend to the lunar surface, Collins would remain in orbit around the moon aboard the command module, waiting for their return. Together, the 3 astronauts prepared for the most important mission of their lives. On July 16, 1969, the Saturn V rocket stood at the Kennedy Space Center in Florida. Towering hundreds of feet above the ground, it represented decades of scientific progress and engineering achievement. At the top of the rocket sat the Apollo spacecraft. Inside were 3 people preparing to travel farther than anyone in history. Millions of people gathered to watch. Millions more followed the mission through television and radio. The countdown reached 0. The engines ignited. And Apollo 11 began its journey. Slowly at first, then faster and faster, the massive rocket climbed away from Earth. The spacecraft disappeared into the sky, carrying humanity's hopes with it. After reaching Earth orbit, Apollo 11 began the journey toward the moon. For 3 days, they moved farther away from home. Earth grew smaller behind them. The moon grew larger ahead. On July 19th, Apollo 11 entered lunar orbit. The astronauts were now circling another world. The next day, Armstrong and Aldrin entered the lunar module, named Eagle. Collins remained aboard the command module, Columbia, continuing his lonely orbit above the moon. The separation marked the beginning of the most dangerous part of the mission, the descent. As Eagle moved away from Columbia, 2 astronauts began their journey toward the lunar surface. The lunar module fired its engines. The moon approached, but the descent was not perfect. As the spacecraft approached the surface, alarms appeared inside the lunar module. The astronauts had to remain calm. Mission controllers on Earth analyzed the situation and determined that the landing could continue. Then another challenge appeared. The original landing area was filled with large rocks and uneven terrain. Armstrong took manual control of the spacecraft and searched for a safer location. Fuel was running low. Every second mattered. The world waited. Then, at 2017 Universal Time Coordinated on July 20th, 1969, Eagle landed on the moon. Humanity had reached another world. The message from Armstrong was calm and unforgettable. The Eagle has landed. For everyone listening on Earth, the moment felt almost unreal. A human being had just reached the surface of the moon. But the journey was not finished. The astronauts still had to step outside. Several hours after landing, Neil Armstrong opened the hatch of the lunar module. Slowly, carefully, he climbed down the ladder. His foot moved toward the lunar surface. Then he stepped into history. On July 20th, 1969, Neil Armstrong became the first person to walk on the moon. His words traveled across space and reached millions of people around Earth. One small step for man, one giant leap for mankind. The phrase captured the meaning of the moment. This was not only an achievement for one country. It represented something larger. The ability of humans to imagine something impossible and then make it real. Soon after, Buzz Aldrin joined Armstrong on the surface. Above them, Michael Collins continued orbiting alone. While Armstrong and Aldrin walked on the surface, Collins carried the responsibility of keeping the mission alive. He waited in the command module, knowing that the success of the entire mission depended on the three astronauts returning together. The moon itself was unlike any place humans had ever visited. There was no wind or sound. The landscape was silent. The astronauts moved carefully across the surface, leaving footprints that would remain untouched for millions of years. After completing their work, Armstrong and Aldrin returned to Eagle. The lunar module launched from the moon's surface and reunited with Collins in orbit. The three astronauts were together again. The journey home began. On July 24th, Apollo 11 returned safely to Earth, splashing down in the Pacific Ocean. The mission was complete. Humans had traveled to another world and returned safely. The impossible had become reality. The moon landing represented the greatest achievement of the space race. It was the result of generations of curiosity, decades of scientific progress, and years of determined effort. From the first dreamers who imagined reaching the stars, to the engineers who built the rockets, to the astronauts who stepped onto another world, every person had contributed to the journey. That night, people around the world looked up at the moon differently. It was no longer only a distant light in the sky. It was a place where humans had stood, a place where footprints remained, a place that proved how far curiosity could take us. The space race had reached its defining moment. Humanity had touched another world. And for the first time in history, the moon was no longer just something we watched.
It was somewhere we had been.
The first footsteps on the moon were a moment unlike anything humanity had ever experienced. When Neil Armstrong and Buzz Aldrin stepped onto the lunar surface during Apollo 11, they accomplished a goal that had once seemed impossible. A dream that had existed for thousands of years had become reality. But the journey did not end there. The moon landing was not meant to be a single visit. NASA had spent years preparing for lunar exploration, and now the agency wanted to learn more about Earth's nearest neighbor. The first landing proved that humans could reach the moon. The missions that followed would discover what humans could do once they arrived. The later Apollo missions would become more ambitious. Astronauts would travel farther across the lunar surface. They would conduct more scientific experiments. They would collect larger amounts of lunar material. And they would begin to understand the moon as a real place rather than a distant object in the sky. The second crew to land on the moon was Apollo 12. Launched on November 14, 1969, the mission carried astronauts Charles Pete Conrad, Alan Bean, and Richard Gordon. Unlike Apollo 11, which focused primarily on achieving the historic first landing, Apollo 12 was designed to demonstrate precision. NASA wanted to prove that future missions could land exactly where they intended. The mission targeted an area near an earlier unmanned spacecraft called Surveyor 3, which had landed on the moon in 1967. Apollo 12 successfully reached the lunar surface in November 1969. Astronauts Pete Conrad and Alan Bean explored the moon while Richard Gordon remained in lunar orbit aboard the command module. The mission was a success. The astronauts collected samples, photographed the surface, and retrieved parts from Surveyor 3 to help scientists understand how equipment changed after years exposed to the lunar environment. Apollo 12 showed that the moon was not simply a place to visit once. It was a place where humans could work. The next mission, however, would become one of the most dramatic moments in the history of space exploration. Apollo 13 launched on April 11, 1970. The crew included Commander Jim Lovell, Lunar Module Pilot Fred Hayes, and Command Module Pilot Jack Swigert. Their goal was to land on the moon and explore a region called the Fra Mauro Highlands. But 2 days into the mission, something went wrong. A tank inside the spacecraft's service module exploded. The damage was severe. The command module lost much of its oxygen supply and electrical power. The mission to land on the moon was immediately abandoned. Now the goal was much simpler: survive. The astronauts and mission controllers on Earth faced an unprecedented emergency. The spacecraft was too damaged to return directly using normal procedures. Instead, they used the lunar module as a lifeboat. The small vehicle designed to carry astronauts from lunar orbit to the moon's surface would now help carry them safely home. The situation required careful decisions and teamwork. Engineers on Earth worked around the clock, creating solutions with limited time and resources. The astronauts conserved power. They rationed supplies. They followed procedures developed during training but never expected to use in such a serious emergency. The world watched as Apollo 13 traveled around the moon and began its journey back to Earth. On April 17, 1970, the spacecraft safely returned. The astronauts survived. The mission had failed in its original purpose, but it became one of the greatest examples of problem-solving and teamwork in space history. The famous phrase associated with the mission captured the urgency of the situation. "Houston, we've had a problem." Apollo 13 reminded the world that space exploration was not only about moments of triumph. After Apollo 13, NASA continued moving forward. Apollo 14 launched in early 1971, carrying astronauts Alan Shepard, Stuart Roosa, and Edgar Mitchell. Alan Shepard, one of the original Mercury astronauts and the first American in space, finally reached the moon nearly a decade after his historic flight. Apollo 14 successfully landed in the From Mara region, the same area Apollo 13 had been unable to explore. Then came Apollo 15. This mission represented a major change in lunar exploration. For the first time, astronauts brought a lunar rover to the moon. The small electric vehicle allowed astronauts to travel farther from their landing site and explore more territory than previous missions. Apollo 15 astronauts David Scott and James Irwin traveled across the lunar surface, studying geological formations and collecting samples from areas that had never been visited. The moon became more than a place where astronauts planted flags. Apollo 16 continued this work in 1972. Astronauts John Young and Charles Duke explored the lunar highlands, studying ancient rocks that provided clues about the moon's formation. The mission helped scientists understand that the moon had a complex geological history. The final Apollo mission to the moon was Apollo 17. Launched in December 1972, it carried astronauts Eugene Cernan, Harrison Schmitt, and Ronald Evans. Apollo 17 became the most extensive lunar exploration mission of the program. Eugene Cernan and Harrison Schmitt spent more time on the lunar surface than any previous astronauts. They traveled farther using the lunar rover, collected more samples, and conducted detailed scientific research. Harrison Schmitt was the only professional scientist to walk on the moon, bringing geological expertise to the mission. When Eugene Cernan climbed back into the lunar module, he became the last human to walk on the moon. At the time, no one knew how long it would be before another person followed. The Apollo missions had accomplished something extraordinary. Humans had traveled to another world. They had explored its surface. But the moon landings also marked the beginning of the end of the space race. The original competition between the United States and Soviet Union had reached its conclusion. The goal had been achieved. The first footprints had been made. The great race to the moon was over. Yet the legacy of Apollo continued. The knowledge gained from these missions influenced future spacecraft, scientific research, and humanity's ongoing exploration of space. The moon remained silent above Earth, just as it had for billions of years. But now it carried something new. The marks of human presence. Footprints. Experiments. Memories. A reminder that a species from one small planet had looked upward and found a way to reach another world. The space race had begun with competition. It started with a satellite drifting silently above Earth. It continued with the first human journeys beyond the atmosphere. It grew into a contest between two powerful nations, each determined to prove the strength of its science, technology, and imagination. For more than a decade, the United States and the Soviet Union pushed each other forward. Every achievement inspired another attempt. Every success created a new challenge. The competition brought moments of incredible discovery and moments of intense pressure. But by the early 1970s, the race that had defined the previous decade was beginning to change. The moon had been reached. The impossible had been accomplished. And the relationship between the two space powers was slowly beginning to shift. The original goal of the space race had been to demonstrate superiority. Space achievements were seen as symbols of national strength during the Cold War. The first satellite, the first human in orbit, the first spacewalk, the first moon landing. Each milestone carried meaning far beyond science. But after the Apollo moon landings, the focus began to move from competition toward cooperation. The United States and Soviet Union both recognized that space exploration was expensive, dangerous, and complex. Working together offered new possibilities. The first signs of this changing relationship appeared in scientific discussions and diplomatic efforts. After years of rivalry, both nations began exploring ways to cooperate in space. This eventually led to one of the most symbolic missions of the era, the Apollo-Soyuz test project. Before this historic mission, the United States and Soviet Union had followed very different paths in space. NASA had developed large programs focused on lunar exploration. The Soviet Union had continued building its own spacecraft and orbital missions. Their astronauts and cosmonauts had trained separately. Their engineers had developed different technologies. But in 1975, the two nations decided to bring their spacecraft together. The mission involved an American Apollo spacecraft and a Soviet Soyuz spacecraft. The goal was not exploration of a new world. It was something more peaceful. Cooperation. On July 15, 1975, both spacecraft launched. The Apollo spacecraft carried astronauts Thomas Stafford, Vance Brand, and Deke Slayton. The Soyuz spacecraft carried cosmonauts Alexei Leonov and Valery Kubasov. After reaching orbit, the two spacecraft performed a carefully planned rendezvous. For the first time, American astronauts and Soviet cosmonauts joined together in space. They shook hands. They shared meals. They exchanged gifts. They conducted scientific experiments. The mission represented a remarkable change from the tense competition that had defined the early space race. The same nations that had once competed to reach the moon were now demonstrating that space could become a place for collaboration. The Apollo-Soyuz mission did not erase the rivalry between the United States and Soviet Union. The Cold War continued, but it showed that even during periods of disagreement, cooperation was possible. The space race had transformed humanity's relationship with space. Before the 1950s, space exploration existed mostly in imagination. Scientists dreamed of rockets. Writers imagined distant worlds. People looked at the stars and wondered what might be possible. Then, within a single generation, humans had created machines that could leave Earth. They had built spacecraft. They had sent explorers beyond the atmosphere. They had walked on the moon. The achievements of the space race were not just about reaching a destination. They were about learning. The technology developed during this period influenced countless areas of science and engineering. Computing systems became more advanced. Communication technology improved. Materials science progressed. Scientific understanding of Earth and space expanded. Satellites became an essential part of modern life, helping with weather forecasting, navigation, communication, and scientific research. The space race also changed the way humans viewed Earth. Before astronauts traveled into space, most people had never seen the planet as a whole. The photographs taken during missions like Apollo 8 revealed something powerful. Earth was a small, beautiful world surrounded by darkness. There were no visible borders. No divisions, just one shared home. The images inspired environmental awareness and encouraged people to think differently about humanity's relationship with the planet. The view from space showed that Earth was both incredibly special and incredibly fragile. The space race also changed the idea of what humans could accomplish. It demonstrated the power of cooperation between science, engineering, and imagination. A moon landing required more than rockets. It required mathematicians solving complicated equations, factory workers building precise components, doctors studying human health, programmers creating new systems, teachers inspiring future generations. Millions of people contributed to the achievement. The astronauts who flew the missions became symbols of courage, but they were only one part of a much larger story. The space race belonged to everyone who helped make it possible. By the mid-1970s, the world was entering a new era of space exploration. The dramatic race to the moon had ended. The next chapter would focus on long-term presence in space. Instead of short journeys, humans would begin learning how to live and work in orbit for extended periods. Space stations would become the next frontier. Reusable spacecraft would be developed. International cooperation would slowly become more common. The dream was no longer simply reaching space. It was staying there. The space race had begun as a competition between two nations. But its greatest achievement belonged to all humanity. It showed that humans could accomplish things that once seemed impossible. A small species living on one planet had reached beyond the atmosphere and touched another world. The moon landing was not just a victory for one country. It was a milestone for everyone who had ever looked upward and wondered. The night sky remained the same. The stars continued to shine. The moon continued its quiet journey around Earth. But humanity had changed. We were no longer only observers of the universe. We had become explorers. And the journey had only just begun. The moon had been reached. The great race between the United States and the Soviet Union had achieved its most dramatic goal. Humans had traveled across the vast distance between Earth and the moon. They had landed on another world. They had returned safely home. But after the excitement of the Apollo missions, a new question emerged. What would come next? Exploration had always been about moving farther. But sometimes, progress required learning how to stay. The next great challenge was not traveling to another world. It was learning how humans could live and work in space for longer periods of time. A journey to the moon lasted only a few days. A future mission to Mars or deeper into the solar system would require months or even years. Before humanity could travel farther, it needed to understand how people could survive away from Earth for extended periods. The answer would come from space stations. Instead of sending astronauts on brief missions and returning them home, a space station would provide a place where humans could remain in orbit and conduct long-term research. The United States' first major space station was called Skylab. Launched in 1973, Skylab represented a new direction for American space exploration. The focus was no longer simply on reaching new places. It was on learning, understanding, experimenting, living in space. Skylab was built from the upper stage of a Saturn rocket and transformed into a large orbital laboratory. Unlike the small capsules of earlier programs, Skylab provided astronauts with room to move, work, and conduct experiments. It contained sleeping areas, workspaces, scientific equipment, and even a small area where astronauts could exercise. For the first time, humans would spend significant amounts of time living above Earth. But getting Skylab into orbit was not easy. Shortly after launch, the station experienced serious problems. A protective shield that was supposed to protect Skylab from sunlight and small particles was damaged. One of its solar panels was lost. The remaining power system was affected. The station was in danger of becoming unusable. Engineers on Earth quickly began searching for solutions. The astronauts who would visit Skylab trained to help repair the damaged station. The mission became a test of creativity and determination. The first Skylab crew launched in May 1973. Astronauts Charles Conrad, Paul Weitz, and Joseph Kerwin reached the damaged station and worked to restore its systems. They installed a sunshade to reduce temperatures inside the spacecraft. They repaired equipment. They found ways to make Skylab functional. Their efforts saved the mission. What had begun as a potential disaster became an impressive achievement. Over the next several months, 3 different crews lived aboard Skylab. They conducted hundreds of experiments. They studied the effects of weightlessness on the human body. They observed Earth using advanced instruments. They studied the sun in ways impossible from the ground. Skylab gave scientists a new understanding of our planet and our place in space. One of the most important areas of research involved the human body. Living in microgravity created challenges. Without the constant pull of Earth's gravity, astronauts experienced changes in their muscles, bones, and balance systems. The body that had evolved for life on Earth had to adapt to an entirely different environment. Skylab experiments helped scientists understand these changes. This knowledge became essential for future missions. Astronauts who would eventually spend months aboard the International Space Station would rely on discoveries made during Skylab. The station also provided a remarkable view of Earth. From orbit, astronauts watched weather systems move across continents. They observed oceans, mountains, and deserts from a perspective unavailable to people on the ground. The Earth appeared connected and delicate. Skylab continued the transformation that began with Apollo 8's famous Earthrise photograph. Space exploration was changing how humanity understood its home. The final Skylab crew spent 84 days in orbit, setting a new record for American spaceflight at the time. Their mission demonstrated that humans could live in space for extended periods. The dream of a permanent human presence beyond Earth was becoming more realistic. However, the end of Skylab also reflected the changing priorities of the space program. After the excitement and expense of the moon missions, public attention began to shift. The Apollo program had accomplished its goal. The United States had won the race to the moon. Now, maintaining the momentum of human spaceflight required a new vision. That vision would come in the form of reusable spacecraft. For decades, rockets had been used once and discarded. A new idea emerged. What if a spacecraft could launch, return to Earth, and fly again? What if space travel could become more routine? This idea led to the development of the Space Shuttle. The shuttle represented a major change in how humans approach space. Instead of building a new spacecraft for each mission, NASA hoped to create a reusable vehicle capable of carrying astronauts and equipment into orbit repeatedly. The goal was to make space more accessible. The Space Shuttle would carry satellites, conduct scientific experiments, help build space stations, and continue humanity's exploration beyond Earth. The transition from Apollo to the shuttle era marked the end of one chapter and the beginning of another. The early space race had been about proving that humans could reach space. The Apollo missions had proven humans could reach another world. Now the challenge was learning how to operate in space more regularly. The dream of exploring the universe was becoming less about a single historic moment and more about creating a lasting human presence beyond Earth. Skylab was an important step toward that future. It taught scientists and astronauts what it meant to live away from the planet. It revealed the challenges of long-duration spaceflight, and it showed that humans could adapt to life among the stars. The journey that began with Sputnik had transformed completely. A small satellite had opened the door. A human had walked on the moon. Now people were learning how to build a home in orbit. The universe remained vast. The mysteries remained endless. But humanity had begun the process of becoming a spacefaring civilization. After the triumph of the Apollo program and the experiments of Skylab, NASA entered a new chapter. The dramatic race to the moon was over. The world had watched astronauts travel to another world, but now the question became something different. Could space exploration become a regular part of human life? Could spacecraft be built to fly again and again? Could humans create a more permanent connection between Earth and orbit? The answer would come in the form of a revolutionary new vehicle, the Space Shuttle. Unlike the rockets of the Apollo era, which were designed for single missions, the Space Shuttle was created with the idea of reuse. It was not meant to be a one-time journey. It was meant to become a spacecraft that could launch, return to Earth, and fly again. The concept represented a major shift in the way NASA imagined the future of space exploration. The early years of spaceflight had been about achieving firsts: the first satellite, the first person in space, the first moon landing. The shuttle era would focus on making space more accessible. The program officially began in the 1970s after NASA studied different designs and possibilities. Engineers envisioned a spacecraft that could carry astronauts, scientific equipment, and satellites into orbit. The shuttle would launch vertically like a rocket but return to Earth like an airplane. The final design consisted of several major components. The orbiter was the spacecraft itself, where astronauts lived and worked. 2 solid rocket boosters provided additional power during launch. A large external fuel tank supplied the engines with fuel. After launch, the boosters and tank were separated, while the orbiter continued into space. When the mission ended, the orbiter would glide back through the atmosphere and land on a runway. It was unlike anything humans had built before. The first space shuttle to fly was not actually launched into orbit. It was called Enterprise and was used for atmospheric testing. In 1977, astronauts tested the vehicle's ability to separate from a modified aircraft and glide safely back to Earth. The lessons learned from Enterprise prepared NASA for the first orbital mission. On April 12, 1981, the Space Shuttle era officially began with the launch of Columbia. The mission was called STS-1. Astronauts John Young and Robert Crippen climbed aboard Columbia for the first test flight into orbit. For the first time, humans launched into space aboard a spacecraft designed to be reused. The mission demonstrated that the shuttle could perform as planned. The vehicle reached orbit, completed its objectives, and returned safely to Earth. Over the following years, space shuttles carried out a wide variety of missions. Unlike Apollo, which focused on reaching the moon, the shuttle program focused on activities closer to Earth. The orbiters became laboratories. They carried satellites. They conducted scientific experiments. They helped construct new space technology. One of the shuttle program's most important contributions was launching and servicing satellites. The shuttle's large cargo bay allowed astronauts to carry massive spacecraft into orbit. The shuttle also played a major role in astronomy. In 1990, Space Shuttle Discovery carried one of the most important scientific instruments ever created into orbit, the Hubble Space Telescope. Placed above Earth's atmosphere, Hubble could observe the universe without the distortion caused by air. It transformed our understanding of space. The shuttle also became a symbol of international cooperation. Astronauts from different countries flew together on missions. Scientists around the world contributed experiments. The program helped create a more connected approach to exploring space. But the shuttle era was not without challenges. The complexity of the vehicle made it difficult and expensive to operate. Each mission required careful preparation and thousands of people working together. The same technology that made the shuttle impressive also made it complicated. The greatest tragedy of the program occurred on January 28, 1986. The Space Shuttle Challenger launched from Kennedy Space Center carrying 7 astronauts. Among the crew was Krista McAuliffe, a teacher who had been selected to participate in NASA's Teacher in Space project. Millions of people watched the launch, including many students following the mission because of McAuliffe's involvement. Shortly after liftoff, the shuttle broke apart. The accident shocked the world. The 7 astronauts aboard Challenger lost their lives. The tragedy forced NASA to examine the shuttle program carefully. Investigations revealed technical problems and failures in decision-making processes. The shuttle fleet was grounded while engineers redesigned systems and improved safety procedures. The loss of Challenger was a painful reminder that space exploration remained dangerous. No matter how advanced technology became, human spaceflight always carried risk. The program eventually returned to flight. The shuttle missions continued for decades, contributing greatly to science and exploration. Astronauts conducted experiments in microgravity. They repaired satellites. They helped build the International Space Station. They continued humanity's presence beyond Earth. Another tragedy occurred in 2003 when Space Shuttle Columbia was lost during re-entry, killing 7 astronauts. Once again, NASA faced a difficult period of reflection and change. The accident highlighted the challenges of operating complex spacecraft and led to further improvements in safety. The shuttle program continued until 2011. The final mission, STS-135 aboard Atlantis, marked the end of an era. After 30 years of flights, the space shuttle had carried hundreds of astronauts into orbit. It had changed the way humans traveled to space. It represented both human creativity and the dangers of exploration. But its legacy was significant. The spacecraft transformed space from a place visited only during historic missions into a workplace where humans could conduct research and build something lasting. The space shuttle era showed that exploration was not only about reaching distant destinations. It was also about learning how to remain there. The moon landing proved humanity could leave Earth. The shuttle proved humanity could continue returning. And as the shuttle era came to an end, another great project was taking shape. A permanent home in orbit. A place where astronauts from around the world could live and work together. The next chapter of human space exploration was already beginning. The story of the space race is a story of ambition. It is a story of curiosity. It is a story of people looking upward at the night sky and wondering what might be possible. For all of human history, the stars had been something distant. They were lights in the darkness. They were objects of wonder. They were mysteries waiting to be understood. But in the middle of the 20th century, humanity took its first steps toward changing that relationship. The journey began with a small satellite. In 1957, the Soviet Union launched Sputnik, the first artificial object to orbit Earth. The achievement lasted only a few months in the grand timeline of history, but its impact was enormous. A simple signal traveling through space announced that humanity had entered a new age. The universe was no longer only something we observed. It was somewhere we could go. The launch of Sputnik created urgency around the world. The United States responded by expanding its scientific efforts, creating new organizations, and investing in the technology needed to explore space. The competition between two nations became one of the greatest scientific challenges humanity had ever attempted. The Cold War rivalry between the United States and Soviet Union pushed both countries to accomplish extraordinary things. The Soviet Union achieved many early milestones. It sent the first living creature into orbit. It launched the first human into space. Yuri Gagarin's journey around Earth proved that humans could survive beyond the atmosphere. The United States answered with its own achievements. The Mercury program demonstrated that American astronauts could reach space. The Gemini program taught them how to live and work there. Every mission added another piece of knowledge. Every challenge brought new solutions. The space race was not won by one single invention or one single person. It was built by thousands of people working together. Engineers designed machines that seemed impossible. Scientists solved problems that had never been encountered before. Technicians assembled spacecraft with incredible precision. Mathematicians calculated paths through the darkness of space. Doctors studied how the human body responded to an entirely new environment. And astronauts accepted the risks of becoming explorers. The journey was not easy. There were failures. There were setbacks. There were moments of heartbreak. The tragedy of Apollo 1 reminded the world that space exploration carried real danger. The loss of brave astronauts forced NASA to improve, adapt, and continue forward with greater care. Their sacrifice became part of the foundation that made future successes possible. The dream continued. In 1968, Apollo 8 carried humans farther from Earth than ever before. For the first time, astronauts traveled to the moon and looked back at their home planet from another world. The famous image of Earth rising above the lunar horizon changed how people saw their place in the universe. Earth appeared small, fragile, beautiful, a single home floating through an endless ocean of darkness. Then came the moment that defined the space race. On July 20th, 1969, Apollo 11 landed on the moon. Neil Armstrong stepped onto the lunar surface and spoke words that would become remembered forever. A human being had walked on another world. The achievement was not only a victory for science or a triumph for one nation. It was a moment for all humanity. It showed what could happen when people combined imagination, knowledge, and determination. The moon landings that followed expanded our understanding of another world. Astronauts explored the lunar surface. They collected samples. They conducted experiments. They transformed the moon from a distant object into a place humans had visited. But the space race was not only about reaching the moon. Its legacy continued afterward. The Skylab program taught humans how to live and work in orbit. The Space Shuttle created a new era of reusable spacecraft. Space stations became places where nations could cooperate. Technology developed for space exploration found its way into everyday life, improving communication, science, medicine, and countless other fields. Perhaps the greatest achievement of the space race was not a rocket or a spacecraft. It was a change in perspective. Before space exploration, humanity had always looked at Earth from the ground. We saw oceans and continents. We saw nations and borders. But from space, astronauts saw something different. They saw one planet, one shared home. The view from above reminded humanity that despite our differences, we all live together on the same small world. The space race also revealed something important about the human spirit. Exploration is not easy. The unknown is intimidating. Every journey beyond familiar boundaries carries uncertainty. But throughout history, humans have always chosen to explore. We crossed oceans. We climbed mountains. We studied the deepest parts of Earth. And eventually, we reached beyond the atmosphere. The space race was one of the greatest examples of this instinct to discover. It was born from competition, but it created knowledge that benefited the entire world. It began with two nations trying to prove themselves. It ended with humanity proving something about itself. We are capable of extraordinary achievements. We can solve problems that seem impossible. We can travel farther than anyone imagined. We can transform dreams into reality. Today, when we look toward the moon, we are not only seeing a distant object in the sky. We are seeing a place where humans have stood. When we look at the stars, we are not only looking into the unknown. We are looking toward future possibilities. The story of the space race is not finished. The exploration that began with Sputnik continues through space stations, robotic missions, and new efforts to return humans to the moon and travel even farther. The universe remains vast. There are still worlds we have never visited, questions we have not answered, discoveries waiting to be made. But the first great leap has already happened. Humanity looked upward and decided that the sky was not a boundary. It was an invitation. From the first quiet beep of Sputnik to the footprints left on the moon, the space race showed what happens when curiosity meets determination. The universe is enormous. The journey ahead is long. But as long as humans continue to wonder, explore, and dream, there will always be another horizon waiting.
Good night.